So welcome to problem 4-5, which I'm guessing will be a not too long problem. So in problem 4-5, we consider again a bivariate density for x1, x2, given as this thing here. And as soon as you see such an expression, your brain should just be screaming like gamma, 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 either gamma distribution or inverse distribution, because you guys might recall that this symbol stands for either the game of hangman or the symbol for gamma in the Greek language. So gamma. And what we are asked to show here is to show that x1 and x2 are independent. So that's what we're asked to do in A. And then in B, find the distributions, find the marginal distributions for x1 and x2. So normally when you're asked to find the distribution for something, it can mean sort of three different things. It can mean find the density, or it can mean find the distribution function, and sometimes it can also mean just find the name of the distribution, such as this thing is normally distributed. So depending on the context, it can be either one of those three. And well, what we see here is quite clearly there is some gamma going on. So we're kind of guessing that some gamma will be involved here. Yes. Okay. So we're asked to show in A that x1 and x2 are independent. Now, how do we do that? We can do it in a multiple number of ways. So by definition, when x1 and x2 have densities, so if x1 has density f1, and if x2 has density f2, then x1 and x2 are independent if and only if the simultaneous distribution has a density that can be split up into the product of the marginal densities. So this is the definition of, or this is one of the definitions for independence of two stochastic variables that have densities. So what we just learned, though, in problem 4-4, from problem 4-4, we just learned that we may conclude that x1 and x2 are independent if there exist two functions. So if there exist non-negative functions g1 and g2, which satisfy that we can take the simultaneous distribution of x1 and x2 and split it up into one expression that only relies on x1 and another expression that only relies on x2 multiplied together. And when you look at these two different ways to show that x1 and x2 are independent, then it kind of seems like this way down here is easier, right? Because here we only need g1 and g2 to be non-negative, whereas up here you actually need to find the correct density. So we are going to use the criteria from problem 4-4 instead. And then afterwards we're asked to find the marginal distributions of x1 and x2. So We're going to show both answers in the next video. If you've already got the idea of what's going on here, then you're very welcome to just solve the problem on your own, because I think you've actually got enough to just solve this. But apart from that, if you really want to see the solution as well, then just watch on in the next video.